Okay, let's move on to the next example here. So we've got another rational expression. Now, real fast. These are not short problems, but they are the hardest thing that we'll be doing, and they're the last thing we have to learn this semester. So let's power through. You're doing great. Let's keep working on this. Once we master this, we can just look back on the semester, review, and get ready for our midterm. So that's good news, right? So the first step is to factor everything. Okay, so the question here is there anything to factor? So if we look at our polynomials here, we've got p minus 5. That's linear. Can't factor that. We've got p minus 4. That's also linear. We can't really factor that. We have a p plus 4, which is, again, linear. So really, in this whole rational expression, there's nothing to factor, just like that video we did last time, which we can move on to step 2. Step 2 is to get rid of all of our denominators. So how are we going to do that? There's two ways we learned. We can cancel any matching factors. Cancel matching factors. Are there any matching factors? There's no 2 in the numerator here. There's no 2 in the numerator here. And there's no p plus 4 in the numerator here. So there's nothing to cancel. So the only other thing we know how to do is to multiply both sides of the equation by the least common denominator. So let's do that. What is my least common denominator? Well, again, it's whatever the smallest thing we can multiply by the whole equation is that could get rid of all our denominators for us. So let's look at it this way. If I write my equation like this, where I've got both sides kind of separated out into 2 parentheses, and then I have just little gaps here where I can write the LCD that I'm going to multiply. Okay, let's try to figure out what could my LCD be that would get rid of all my denominators. Well, this denominator is just 2. So if I'm going to multiply this by something that has to get rid of the 2, that something's got to have a 2 in it. This denominator also has a 2 in it. That 2 is taken care of by that 2. Okay? And this denominator has a p plus 4 in it, which means if I'm going to get rid of it, if I'm going to cancel it with something, the LCD that I multiply everything by has to have a p plus 4 in it as well. So my least common denominator turns out to be 2 times p plus 4. So let's multiply both sides of my equation by 2 times p plus 4. And then this side, 2 times p plus 4. Okay, there. Now I've multiplied both sides of my equation by my least common denominator. So let's multiply that least common denominator into my equation. Remember, when you multiply fraction by some other number, it multiplies into the numerator, but it doesn't touch the denominator. The denominator stays the same. Okay, so on the other side, I've got 2 times p plus 4. That's going to distribute into both of these rational expressions. Okay, so here's the first rational expression. It's going to be 2 times p plus 4 times p minus 4, all over 2. And then my second rational expression is going to be it's going to be 2 times p plus 4 times 1, but anything by 1 times 1 is just itself. So I'm just going to write 2 times p plus 4 over p plus 4. Now, what cancels here? Obviously, every denominator should cancel. That was the whole point of multiplying by my least common denominator. So if I cancel everything out like that, cancel the matching factors. Now, what do I have left? I've got p plus 4 times p minus 5 is equal to p plus 4 times p minus 4 plus, and then all that's left in my final rational equation is just the 2. That's the only thing that didn't cancel there. Okay, so now I've got everything out of my denominators. No more denominators. I can move on to step 3, which is to multiply everything. And in this case, I do have a step 3. I've got 2 polynomial multiplication problems inside of my equation. Okay, I'm going to use box method to do the multiplications because I like box method. I think you should too. It's a good method. Okay, so for the first equation, p plus 4 times p minus 5. I'm going to put a p and a positive 4 on one side, representing p plus 4. And I'm going to put a p and a minus 5 on the other side, representing p minus 5. So in this box is p times p, that's p squared. In this box is 4 times p, which is 4p. In this box is negative 5 times p, that's negative 5p. In this box is negative 5 times 4, that's negative 20. Okay, one more multiplication problem to do, which is p plus 4, p minus 4. So I'm going to put p plus 4, p and a positive 4 on the outside, just like last time. And now I've got a p minus 5 on the top, instead of, or p minus 4 instead of a p minus 5 on the top. So here's my multiplication is p times p is p squared in that box. Negative 4 times p is negative 4p in that box. 4 times p is 4 times p in that box. And then I've got, in my final box, I've got a 4 and a negative 4. And that's going to make a negative 16. Okay, so if this multiplication problem, well, actually, let's say this first. I just want to remind you, one of the cool things about box method is that like terms line up on the diagonal. So you can see I've got my p terms all lined up here on the diagonal. And I've got my p terms all lined up here on the diagonal as well. Okay. So what I'm going to do now is I'm going to rewrite this equation, but with the multiplication problems all written out. So p plus 4, p minus 5 multiplied together, that's going to give me p squared. And then combine my like terms, I've got 4p minus 5p, that's negative 1p. And then I've got a negative 20. And that's equal to, now here I've got p plus 4, p minus 4, and I just figured out that the answer to that is p squared. Then combine my like terms, I've got 4p and negative 4p. That's 0p, that comes out to no p's, so I don't even have to write that part. And then I've got a negative 16, negative 16. Now real quick, you might notice, look, this is a difference of squares polynomial. If you factor that, you should get this. A plus b, a minus b. If we had recognized that this was the formula for the factors of a difference of squares polynomial, a plus b, a minus b, we could have just probably skipped right to this step where we wrote a squared minus b squared. But at the same time, it's never a problem to write it all out fully, just in case. So, and then we can't forget the plus 2 at the end. Okay, plus 2 at the end. Before we move on to step 4, I'm just going to simplify this if I can. I'm going to look for any like terms. No like terms on the left side. Where I wrote that p, it makes it look like the page number is cubing the p, but that's just the page number. Pay no attention to that. Is equal to p squared. And then here's our like terms, is I've got two constant terms here. I've got negative 16 and positive 2. If I add those together, I'm going to get negative 14. Okay, so now that I've simplified, I am now going to move on to step 4. Step 4 is to bring everything to one side by adding and subtracting the right terms. So which side am I going to get rid of? I'm up here now. What side am I going to get rid of? It looks like there's fewer terms on this side, so I'm going to try to get rid of that side. I'm going to subtract a p squared to get rid of that p squared term. But if I do that to one side, I got to do it to the other. And then I'm going to add a 14. I'm going to add 14 to get rid of the negative 14. But if I do that to one side again, I've got to do it to the other. Add 14. And now, p squared minus p squared is 0. Okay, no need to write that. Negative p plus 0 is still just negative p. It doesn't change. You can just bring it down. Negative 20 plus 14, that's going to give me negative 6. And then p squared minus p squared should be 0, right? Should give me 0. And then negative 14 plus 14 should also give me 0. So on this side of the equation, I've got just 0, which is, of course, the whole point. That's what I was trying to do, is get rid of everything on one side and just put it all on the other side. Well, that simplified up quite a bit. Can I solve this polynomial equation? I think I can. Let me do this. All I need to do is add p to both sides, If I add p to both sides, then I've got negative 6 is equal to p. So what's p? P is negative 6. Now the question is, and by the way, that was step 5 that I just did, where I solved that polynomial equation that was set equal to 0. I found the zeros here. P is equal to negative 6. Now, P is equal to negative 6 is definitely a solution to this polynomial. But the question is it a solution to the original rational expression as well? Or is it an extraneous solution where it, even though it kind of showed up in our solutions, it doesn't really solve what we started with? Well, to check that, to check for our extraneous solutions, we got to see what are my excluded values. My excluded values, okay? So excluded values are where the denominator equals 0. These two denominators just equal 2. They always equal 2. They don't change. There's no variable in those denominators. This denominator here, p plus 4, that's where there's a variable in the denominator. When would that equal 0? When would p plus 4 equal 0? Well, it equals 0 when p is equal to negative 4. So my excluded value, the only excluded value for this whole rational equation is negative 4. So negative 4 cannot be a solution because it's an excluded value. Is negative 4 the solution I got here? No, it's not. So there's no extraneous solutions. No extraneous solutions. Because the solution I got, extraneous solutions, because the solution that I got was not excluded. There's no reason to exclude this solution. So there's no extraneous solutions. This solution, p is equal to negative 6, really is the answer. Negative 6 is the solution to this rational equation.